Lab 11, the copper cycle. This one's fun. You get to take a piece of elemental copper, and just some copper wire, put it through 5 different reactions, and at the end of the 5th reaction, you end up with the copper by itself again, the elemental copper. So the first reaction that we're going to observe is a redox reaction. Okay, the copper is going from a 0 oxidation state or charge to a 2+ charge. So it is oxidized. Lost 2 electrons. So then you can see you'll have a clear and colorless solution at first, and then you'll get some blue, and that is the copper 2+ in solution. You will also observe some brown gas. And we actually have to do this one in the fume hood because the brown gas is super toxic. And not the kind of toxic where, you know, it'll give you cancer in 20 years. It's the kind of toxic that'll hurt you right now when you inhale it, so careful. So let's draw a picture of what that would look like. Let's draw a before and after picture of your principal species in solution. So here's my before. Just pretend that looks like a beaker. And so we've got our solid copper sitting at the bottom there. We are adding some nitric acid, which is a strong acid, so it completely dissociates into H+ and NO3-. And refer to the lab manual as you go along with this. The lab manual has all of the balanced equations for each reaction. So I'm just drawing the ions in solution. So what happens after it reacts? Like we said, the copper gets oxidized, so it's now aqueous in solution. We still have a bunch of H+. We added way more H+ than we actually needed to, because we wanted to make sure that every last atom of copper was oxidized. We still have some NO3-, some nitrate, and then there's the brown gas that came off of that, or NO2. Okay, next reaction is the precipitation of the copper 2+ into copper 2 hydroxide. So we are going to add sodium hydroxide, a strong base, in excess. Pretty huge excess. And that is going to make the solution basic, as you'll see in a moment. So let's draw our before picture. And that contains everything that we had up here. Everything in the after picture from the previous reaction is going to still be in there. So I've got my copper 2+, I've got my H+, and I've got my NO3-. And additionally, what I've added is some Na+ and some OH- from the sodium hydroxide. Right, so this OH is going to do 2 things. It is going to bond with the copper 2+ to form our precipitate, and it is also going to neutralize any H+ that is still in solution. So this reaction, as we found out in Lab 5, always produces water. So what does that look like? we've got our copper hydroxide, our copper 2 hydroxide as a solid. And we still have some OH minus. That's how much excess we put in there. And we still have the sodium that didn't go anywhere, and our nitrate is still present. So next reaction happens spontaneously. We don't actually have to add anything. It is the dehydration of the copper 2 hydroxide into copper 2 oxide. It's going to lose some hydrogens. So our before picture looks exactly the same. Okay. Okay, so this copper 2 hydroxide just breaks down. It releases the 2 hydrogens and forms water with the OH ions, leaving our solid just as copper 2 oxide, which is a black solid. We can do this because the copper 2 hydroxide is really unstable. Or it's unstable in basic solution. So we have so many excess OH ions that we can do that. And so now we still have some in solution here, some OH ions, the sodium and the nitrate. Oh, didn't go anywhere still. Now at this point, I'd like you to start drawing your own principal species in solution. Do a before and after picture, but figure out what the ions in solution are yourself. Look at the balanced equations in your lab manual. That will help you, and just follow the same technique that we've been doing. Our before picture from the previous thing is, or our after picture from the previous reaction determines our before picture for the next reaction. So after this reaction, one thing you need to know, which you'll see in the experiment, is that you're going to pour off the liquid. And you're going to be asked some questions about what you're removing when you pour off the liquid. So when you write your next principal species in solution, take that into account, the fact that you poured that off. Reaction 4 is an acid-base reaction. The protons from the sulfuric acid that you added are going to attack the oxygen in the copper 2 oxide, leaving the copper 2 ion in solution. It's the oxygen on the copper 2 oxide that's acting as a base. So here I invite you to draw your principal species in solution. Anytime you get stuck on a question in this lab, look back to your principal species in solution, and your answer probably lies there. So our final reaction, we're actually doing 2 reactions, and they're both redox reactions. Okay, so in this case, we're adding a bunch of elemental zinc, and that is in its 0 oxidation state, as all elements are. And it is going to donate some electrons to the copper 2 plus in solution and become oxidized. Right? And that is in turn going to leave the copper reduced. When the copper is reduced, it's restored to its zero oxidation state, which is its elemental state. So make sure you count for both reactions when you draw your principal species in solution. And I will give you a hint here that you do have some gas coming off there, so you can figure out what that is. So after you've finally gotten your copper out of solution, you need to wash your product, your elemental copper. It's, as you've seen when you figured out your principal species in solution, there are tons of ions still in solution that could be stuck to your copper. So you're going to need to wash that with some deionized water and then dry it fairly quickly. And for that, we're going to use methanol and acetone. Those are both solvents that evaporate fairly quickly. And so those end up rinsing off and displacing all of the water and then evaporating, leaving you a dry product that you can then weigh out.